fluid is flowing through a capillary of dimensions shown here, and we're asked to find the amount of time required for the fluid to flow from one end of the capillary to the other. In order to solve this problem, our strategy is to first use the Poisson equation to find the volume flow rate. Then we will find the volume flow rate in terms of the cross-sectional area and the fluid velocity. And finally, from this velocity, we will use the definition of velocity as distance over time to calculate the time it takes for the fluid to travel from one side of the capillary to the other. First, we apply the Poisson equation, where r is the radius of the capillary, delta P is the pressure differential from one side to the other, eta is the viscosity of the fluid, and L is the length of the capillary. Plugging in all the numbers, we can find the volume flow rate to be equal to this number here. Next, we write volume flow rate in terms of the cross-sectional area and the fluid velocity, and then rearrange this equation so that way it is in terms of velocity. We can substitute in the Poisson equation for Q and arrive at this equation here, and then we can plug in the numbers to find that the velocity of the fluid is 0.03 meters per second. Velocity is equal to distance divided by time. The distance the fluid has to travel is L, the length of the capillary. We can then rearrange this equation in terms of time, and then substitute in our equation for the velocity, which we derived, or we could substitute in this number, and then plug in the numbers for the equation to find that it takes the fluid 6.7 milliseconds to travel from one end of the capillary to the other.